Okay. So I tried to write the code in a way that, I'm sorry for bumping the camera, that's easy to read. It's not probably the best written code that anyone ever wrote, but and also Mathematica was very helpful here because it had some functions that made life really easy. So Conway, I make a table. If a number is odd, we give it a 1 and a 0, and then integer digits, the number base 2 tells me, gives me a list of the digits, and then total just adds them up. Yep. Okay, so my first table here, 1 1 0 1 0 0, that's telling me odious, odious, evil, odious, odious. Yep. And then I turn them back just so you can see the odious and evil numbers, 1 2 4, and I put zeros in the spots where, so I didn't compress everything together. I just wanted you to be able to see that we had all the numbers. Where there's a 0 here, there's a number here. And where there's not where there is a number here, like 4, there's a 0 here. You see that? So here are our odious numbers, here are our evil numbers. Okay, so what I did here is next, I looked at the primes. Let's convert the prime numbers, 2, 3, 5, 7, 11, into a list of evil and odious. Yep. And then I have some code down here that goes back. Okay. And again, I didn't write this in the most clever way. I just wrote it to look through until I was bigger than, and then I made a new list. So the primes through Kovanova's process turn into 1, 3, 5, 7, 8, 11, 12, 13, 15, 17. Are those all prime?
Well, no, not 8.
There's even numbers. There's some also non-prime odd numbers, like 25.
Okay.
And 21
and even 15.
Yeah.
Okay, so this transformation didn't turn primes back into primes, but it turned primes into a new list of numbers. Okay. So what kinds of numbers could we look at besides prime numbers? Up here.
Square numbers, maybe?
Ah, okay. Squares. So instead of the ith prime, I'll put in
square
I squared. That's a great idea.
I think you need a... Oh, I know you have a bracket.
All right. So this should be 1 squared, and 1 represents odious, right? So was 1 an odious number?
Yeah.
Yeah.
You can even check our lists up here. This should be 4. Is 4 odious or evil?
4 is odious.
Odious. There it is in our list.
Oh.
Next one is 9.
9 was, I think...
That was evil.
Evil. Yeah. There it is in our evil list. Okay, so it looks like we got them. And then that turns, we run our program down here, and we'll go back and see what it becomes. 1, 2, 3, 4, 7, 9, 11, 13, 14, 16.
We have the squares on here, but we have other numbers too.
Oh, how interesting. Very good noticing.
Well, do we have 36?
I didn't go far enough. I only went to the first 20, but let me go to the first 30.
No.
Oh, dang, it broke. We didn't get 36.
No, did we get 49?
Well,
yeah, we got 49.
Huh.
Well, that was 6 squared, and we had something with groups of 6.
We did. So maybe something's going on there.
Yeah.
Okay. Well, let's go. That was a great idea to look at the squares. What other kinds of sequences, or what other sort of famous mathy sequences do you know? Prime, squares,
Fibonacci numbers?
Fibonacci.
Is it possible to do that?
Yeah. Let's see. Mathematica. I think it's just Fibonacci. One tricky thing here is Fibonacci starts with 1, 1. Fibonacci number 1 probably is going to be 1. Yep, oh, good. At least I remember the notation. Fibonacci number 2 is also probably going to be 1. Okay. So unlike our other numbers, this list in the beginning isn't necessarily increasing.
Yeah.
I could fix that if you want, but let's just do it starting with 1, 1. So it goes 1, 1, 2 is an odious number.
And then
And
3.
Sorry.
3 is evil.
3 is evil.
5 is
5
evil.
is evil.
Yeah.
7 is
8. 8 is
Okay, and so this is we know this won't be the Fibonacci numbers because we're forcing our sequence down here to be increasing. So it's not, it cannot start 1, 1. But instead it goes 1, 2, 4, 5, 6.
And we don't have 3 on here.
Yeah, so we didn't get the Fibonacci numbers
8,
back.
13. We didn't get 21.
How could I fix the little problem here of starting at 1, 1?
Well,
How
you
could
could start at the Fibonacci number 2.
Yeah, do you know how I could change the
Fibonacci
code?
number I plus 1.
Yeah, very good. Fibonacci number I plus 1. Good solution. So here, this should look exactly the same, but just without that 1 at the beginning.
Yeah.
So everything shifted over.
And now
And we go down.
1, 2, 3, 5, 7. Oh, we have 1, 2,
We have
3,
the Fibonacci, but we
8,
don't have 21.
13. We don't have
Oh, we
21.
don't have 21.
We don't have 34.
Huh.
It kind of worked for the first.
This is interesting. So I don't know. This is sort of a neat exercise in kind of just playing around mathematically. Is there anything interesting about these sequences? You know, so we looked at primes, we looked at squares, Fibonacci numbers.
We could do cubes.
Sure, let's do cubes, and then we'll call it a morning. Okay.
Okay.
So cubes, I can just do I cubed.
Okay, so
So I changed it up here to I cubed,
1.
and then we'll run it down here.
It's taking a while. Where is it?
Yeah. 1, 2, 3, 4, 5, 6, 9.
See, we don't have 8.
Yeah, right away we don't have 8, so
20, do we have 27? Yeah, we have 27.
27.
Interesting.
Well, it'd be fascinating to find out the relationship
Yeah.
between these. The only relationship that we know for sure is this sequence down here has the same evil odious pattern in it as the sequence of the cubes. But we don't know if there are any other relationships. And one thing you can notice about this sequence down here on the bottom compared to the cubes is what? For sure. One big difference
Compared to the
sequence of cubes.
Well, there are other numbers aside from the cubes.
Other numbers besides from the cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's the 10th cube?
10th cube. Oh, that would be 10 is 1,000.
1,000. What's our 10th number on this list?
15. So it's much smaller.
Yeah, this sequence doesn't grow nearly as fast. But it does have the same evil odious alternating pattern.
As the cubes.
And so we might ask, what are there other relationships with the cubes? Or we might ask, what other sequences we can start with besides the cubes that go to this sequence? What other sequences have that same pattern? So there's a lot of fun little things from Covanova's blog here. Anyway, good work, guys. That was a fun morning.
Yeah.